Okay, the next thing we have to cover are extrema and critical point. So what does this mean? Extrema just means the maximums and the minimums of a function. So if I have a graph and it goes from -4 to 4, it starts right here, it goes up and then down and then really up and then really down and then womp womp and it ends at 4. Let's say my function looks like this. Extrema means the maximum and minimum points. So there's an extrema here, 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 and here, right? Because that's where the slope changes. It's where there's a top point, a bottom point, a maximum, and a minimum. The first kind of extrema is called an absolute or global extrema. That means the highest, absolute highest, and absolute lowest point on the graph. So in this case, this is our absolute maximum because it never goes higher than this on this interval. And this is our absolute minimum down here, or global. Global and absolute in this case mean the exact same thing. It's when it's at the very highest and very lowest on our interval. The second kind is a relative or local extrema. And that would be all the rest of these. This one, and this one, right? These are relatives because next, compared to everything around it, right, this is still the maximum. Because this is all lower, this is all lower, right? So if you look at this point, like in a vacuum, this point right here is the maximum, like in its area, right? Locally, in its neighborhood, it's the highest in the neighborhood. And then down here, this is the lowest in the neighborhood because everything around it is higher than it, right? It's when it changes. Same with this one over here. It's the maximum, but only locally because there's a higher point, but the higher point isn't like connected to it. So that's pretty much all this section is. You have to be able to recognize where the maximum is and where the minimum is in a function, and whether it's a global or absolute maximum or a relative or local maximum. We're gonna look at a couple examples here. We'll run through it pretty quick because this is more of like looking at graphs. We're not really doing no calculus in this part yet. So let's say, for example, we have these three functions right here, and we have to identify all of the extrema on these graphs. So go ahead, pause it, write down what the extrema are. Draw these graphs and circle it if you're feeling really proactive, you know. Okay, let's go. I'm assuming y'all did it by now. If not, you better do it right now. All right, cool. So on this first graph, well, this is highest point ever. The y value is 3, so we have an absolute maximum of 3 at x equals -2. Okay, cool. And now we'll find the absolute lowest value on this whole graph, which is down here. And we have an absolute minimum of 0 at x equals +2. Now to find the local ones, we have to see other like low points and high points. We have a low point down here and a high point up here. So we have a relative minimum of 1 at x equals -1 and a relative max of 2 at, we'll call that like 0.5. So again, anytime you see a valley down here or a peak up here, you're gonna have a extrema point, relative or not. This is our maximum, even though it's not a peak or like a curve, because it's just the highest point. So the endpoints could be your maximum or minimum, even if it's not a peak or a valley, right? Because it's just the endpoint, it's just the highest point on the graph. And now let's look at our second function. Let's start with that, the absolutes. We have an absolute maximum right here and an absolute minimum right here. So we'll write that absolute max of 3 at x equals 2 and absolute minimum of 0 at x equals 3. And then we'll find our relatives. We have a relative minimum right here and a relative maximum right here. So we have a relative max of 2 at x equals 0 and a relative min of 1 at x equals 1. And now for our last function, we got like a bunch of stuff going on, right? We have all these open circles. It's not a continuous function. Like, what do you do? It's the exact same thing, except some of these points like aren't real points, right? This is an open circle and this is an open circle. So these can't be your absolute maximum or minimum values because there is no value here at -1, right? So we just look for the next thing. We look for minimum, or we look for relative values, and we have a relative minimum right here. So we have a relative minimum of -1 at x equals 1. This is gonna be it for this graph because we have no absolute maximum or minimum values because these are both open circles, and these points on the end are not significant because they're not maximum or minimums. Now, last part of this is we have to learn about critical points. They've just been sitting up here. We have not talked about them. So what those points are is all the points where the slope equals 0, where the tangent line has a slope of 0 or the endpoints on your function. So the critical points on this graph right here could be this because it's the end, this because the slope is 0, this because the slope is 0, and this because the endpoint. So slope of 0 means that just since it's going from up to down, right? This top part here, there's a point where it goes from a positive slope to a negative slope, right? So because of the mean value theorem, this average rate of change from here to here is 0, right? So there has to be a point here where the slope of the whole thing equals 0 because it's going from positive to negative, right? So the positive slope, negative slope, it has to pass 0 at some point. At that point is right at the top up here when it flattens for a second, right? So we can see on our graph, it's flat right here. There's a slope of 0, and it's flat right here where the slope is 0. So any time where the slope equals 0 or the endpoints are called the critical points of a function. So let's say we're looking at this function here, f of x equals x squared plus 2x minus 4 on the interval from -3 to 0. And we have to find all of the critical points of this function. So we're looking for the points where the slope, or f prime of x, equals 0. We're looking for points where the instantaneous rate of change equals 0. So to do that, we have to derive this, and to get f prime of x, this is simple derivatives. You get 2x plus, and then we have to set the f prime of x equal to 0. So we'll go 2x plus 2 equals 0. And then it's algebra, 2x equals -2, x equals -1. So we know that there's a critical point at x equals -1. And we also know that there's a critical point at -3 and there's a critical point at 0 because those could also be your highest or lowest points on your function. So for this function, the critical points, is that how you spell critical, bro? Am I tripping? Okay. This function has critical points at x equals -3, x equals -1, and x equals 0. So anytime you have a function on an interval, there's critical points at the start point, the end point, and any point where f prime of x equals 0. So that's it for this section. We're moving on.